Mechanical engineering is an engineering discipline that applies the principles of physics and material science for analysis, design, manufacturing, and maintenance of mechanical systems. It is the branch of engineering that involves the production and usage of heat and mechanical power for the design, production, and operation of machines and machine tools. It is one of the oldest and broadest engineering disciplines. During the regular classes going on in our laboratory, it can be seen that students are given demonstration about the apparatus which determines the thermal conductivity of a metal bar. The apparatus consists of a brass rod, one end of which is heated by an electric heating coil while the other end projects inside the cooling water jacket. The middle portion of the rod is surrounded by a cylindrical shell filled with insulating powder to maintain the lateral heat transfer minimum from the rod, and thus ensures nearly constant temperature gradient through the length of the rod. Thermocouples are placed at 5 different locations on the bar for temperature measurement of the rod. The heater is provided with a dimmer stat for controlling the heat input. Water under constant head is circulated through the jacket, and its flow rate and temperature rise can be measured using a measuring jar and thermometers. Out of various interesting equipments and instruments used in our metrology and measurement laboratory, profile projector is an advanced equipment. A profile projector is also referred to as an optical comparator or even known as a shadowgraph. It is an optical instrument utilized for measuring. The projector magnifies the profile of the specimen and shows this on the built-in projection screen. From this screen, there is usually a grid that could be rotated 360 degrees. Therefore, the XY axis of the screen could be aligned correctly using a straight edge of the machined part to analyze and measure. This projection screen shows the profile of the sample and is zoomed for better ease of computing linear dimensions. An edge of the sample to analyze could be aligned in the grid on the screen. After that, basic measurements could be obtained for distances along with other points. This is being carried out on a zoomed profile of the specimen. It could be easier and also lessen mistakes by measuring on the magnified projection screen of a profile projector. In our advanced manufacturing laboratory, one of the most interesting machine tools we have used is a CNC turning machine. The term CNC stands for Computerized Numerical Control. Apart from loading and unloading, this machine is controlled by a computer, and rest of the working principles are similar to that of a conventional turning machine. This CNC machine in our laboratory works on numeric automation system. The model name of the CNC turning machine that we are using in our laboratory is CNC lathe tutor. It has a CNC system named Siemens 828D. The elements used here are spindle and servo drives, electrical control unit, hydraulic pump motor, coolant pump motor, lubricant pump motor, air cooler unit, and cheap conveyor motor. According to the machine specification, capacity between center length is 200 mm, maximum machining diameter is 190 mm, and maximum turning length is 200 mm. It has two slides, x-axis which has maximum stroke of 110 mm and z-axis of stroke length 200 mm. Some of the major parts of the CNC turning machine are headstock, where a 3-jaw self-centering chuck is mounted in which the job is clamped using hydraulic power. Next, turret, which has 8 stations to hold 8 different tools for 8 different operations. Next, tailstock, which is generally used to support lengthy jobs. Mechanical engineering workshop is a place where students acquire knowledge on the operation of various processes involved in manufacturing and production. The workshop practice course makes students competent in handling practical work in engineering environment. In our workshop, we have a set of conventional lathes. In this video, the working principle of a lathe machine is being demonstrated to the students under the supervision of our workshop in charge. It can be seen that a metal job is rotating at a high speed on a 4-jaw self-independent chap, and a single point cutting tool is fed against the rotating job longitudinally. Due to this, the material is being reduced in the form of chips. The friction between the workpiece and the cutting tool leads to high amount of heat generation. So, to avoid the damage of the tool and the surface finish of the workpiece, coolant is used. Apart from the lathe machines, our laboratory is also well equipped with shapers, drilling machines, milling machines, and other various welding equipments.